Nitrile rubber, also known as Buna-N, Perbunan, acrylonitrile butadiene rubber, and NBR, is a synthetic rubber copolymer of acrylonitrile and butadiene. Trade names include Nipol, Krynac and Europrene. Nitrile butadiene rubber is a family of unsaturated copolymers of 2-propanenitrile and various butadiene monomers. Although its physical and chemical properties vary depending on the polymer unregistered trademark S composition of nitrile, this form of synthetic rubber is unusual in being generally resistant to oil, fuel, and other chemicals. It is used in the automotive and aeronautical industry to make fuel and oil handling hoses, seals, and grommets, since ordinary rubbers cannot be used. It is used in the nuclear industry to make protective gloves. NBR's ability to withstand a range of temperatures from a 40 to 108 degrees Celsius makes it an ideal material for aeronautical applications. Nitrile butadiene is also used to create molded goods, footwear, adhesives, sealants, sponges, expanded foams, and floor mats. Its resilience makes NBR a useful material for disposable lab, cleaning, and examination gloves. Nitrile rubber is more resistant than natural rubber to oils and acids, but has inferior strength and flexibility. Nitrile gloves are nonetheless 3 times more puncture-resistant than natural rubber gloves. Nitrile rubber is generally resistant to aliphatic hydrocarbons. Nitrile, like natural rubber, can be attacked by ozone, ketones, esters and aldehydes. Production: emulsifier, 2-propanenitrile, various butadiene monomers, radical-generating activators, and a catalyst are added to polymerization vessels in the production of hot NBR. Water serves as the reaction medium within the vessel. The tanks are heated to 30–40 degrees Celsius to facilitate the polymerization reaction and to promote branch formation in the polymer. Because several monomers capable of propagating the reaction are involved in the production of nitrile rubber, the composition of each polymer can vary. One repeating unit found throughout the entire polymer may not exist. For this reason there is also no IUPAC name for the general polymer. The reaction for one possible portion of the polymer is shown below: 1, 3-butadiene plus 1, 3-butadiene plus 2-propanenitrile plus 1, 3-butadiene plus 1. 2-butadiene and nitrile butadiene rubber, monomers are usually permitted to react for 5 to 12 hours. Polymerization is allowed to proceed to 70% conversion before AA-OE short stopper agent is added to react with the remaining free radicals. Once the resultant latex is a OE short stopper, the unreacted monomers are removed through a steam in a slurry stripper. Recovery of unreacted monomers is close to 100%. After monomer recovery, latex is sent through a series of filters to remove unwanted solids and then sent to the blending tanks where it is stabilized with an antioxidant. The yielded polymer latex is coagulated using calcium nitrate, aluminium sulfate, and other coagulating agents in an aluminium tank. The coagulated substance is then washed and dried into crumb rubber. The process for the production of cold NBR is very similar to that of hot NBR. Polymerization tanks are heated to 5–15 degrees Celsius instead of 30–40 degrees Celsius. Under lower temperature conditions, less branching will form on polymers. Properties: the raw material is yellow in color, though it can be orange or red tinted, depending on the manufacturer. Its elongation after fracture is a per mil 300 yen and possesses a tensile strength of a per mil 10 Namibian yen per mass squared. NBR has good resistance to mineral oils, vegetable oils, benzene petrol, ordinary diluted acids and alkalines. An important factor in the properties of NBR is the ratio of acrylonitrile groups to butadiene groups in the polymer backbone, referred to as the ACN content. The lower the ACN content, the lower the glass transition temperature. However, the higher the ACN content, the better resistance the polymer will have to nonpolar solvents as mentioned above. Most applications requiring both solvent resistance and low temperature flexibility require an ACN content of 33%. Applications: the uses of nitrile rubber include disposable non-latex gloves, automotive transmission belts, hoses, O-rings, gaskets, oil seals, V-belts, synthetic leather, printer's roller, and as cable jacketing. NBR latex can also be used in the preparation of adhesives and as a pigment binder. Unlike polymers meant for ingestion, where small inconsistencies in chemical composition structure can have a pronounced effect on the body, the general properties of NBR are not altered by minor structural compositional differences. The production process itself is not overly complex. The polymerization, monomer recovery, and coagulation processes require some additives and equipment, but they are typical of the production of most rubbers. The necessary apparatus is simple and easy to obtain. For these reasons, the substance is widely produced in poorer countries where labor is relatively cheap. Among the highest producers of NBR are mainland China and Taiwan. A hydrogenated version of nitrile rubber, HNBR, also known as HSN, is commonly used to manufacture O-rings for automotive air conditioning systems. In January 2008, the European Commission imposed fines totaling $34,230,000 on the Bayer and Zinn groups for fixing prices for nitrile butadiene rubber, in violation of the EU ban on cartels and restrictive business practices. Criminals have also been known to wear these gloves during the commission of their crimes. These gloves are often chosen because of their tight, thin fit that allows the hands to remain dexterous. Ironically, because of the thinness of these gloves, fingerprints may actually pass through the material as glove prints, thus transferring the wearer's prints onto whatever surface is touched or handled. Dangers: use of these gloves when working with nitric acid or other strong oxidizers can be hazardous. The sample may spontaneously oxidize the gloves on contact, resulting in thermal and chemical burns from both the heat of oxidation and the caustic sample. HNBR, hydrogenated nitrile butadiene rubber, is widely known for its physical strength and retention of properties after long-term exposure to heat, oil, and chemicals. Trade names include Millwright ES, Perbunan, and Nitpol. Depending on filler selection and loading, HNBR compounds typically have tensile strengths of 20-31 per when measured at 23 degrees Celsius. Compounding techniques allow for HNBR to be used over a broad temperature range, -40 to 165 degrees Celsius, with minimal degradation over long periods of time. For low-temperature performance, low ACN grades should be used. High-temperature performance can be obtained by using highly saturated HNBR grades with white fillers. As a group, HNBR elastomers have excellent resistance to common automotive fluids and many industrial chemicals. Like NBR, fluid and chemical resistance improves as the ACN content is increased. The unique properties and higher temperature rating attributed to HNBR when compared to NBR has resulted in wide adoption of HNBR in automotive, industrial, and assorted, performance-demanding applications. On a volume basis, the automotive market is the largest consumer, using HNBR for a host of dynamic and static seals, hoses, and belts. HNBR has also been widely employed in industrial sealing for oil field exploration and processing, as well as rolls for steel and paper mills. XNBR, an improved version of nitrile butadiene rubber, is carboxylated nitrile butadiene rubber. In this execution there are beside the sulfur bridges also carboxyl groups RCOO on the double bond of the butadiene part. These groups will make ionic crosslinks with zinc Zn++ to give improved physical properties as compared to a non-carboxylated nitrile rubber. These ionic crosslinks are formed along with sulfur links. The carboxyl groups which are needed for these extra links are distributed randomly and are present at levels of 10% or less. See also, medical gloves, ozone cracking, references. External links, manufacturing capabilities in nitrile rubber, MERL, Rubber Selection Guide, Nitrile Rubber, AAA Acme Rubber Company, Risk Assessment of Butadiene, CAS number 106-99-0. Inks number 203-450-8, June 2001, Existing Substances Evaluation, Butadiene, The Green Lane, Environment Canada, Antitrust. Commission finds synthetic rubber producers of 34.2 million for price fixing cartel. Europa portal, quality standards for nitrile gloves, information and resource site on nitrile gloves, http www.closer.com/ View solutions page Materials, http www.iisp.com 03 HNBR December 11, 2001 PDF